Hi, this is Mr. Max with Sankofa Mathematics. So today I am looking at paper 2, the paper that was written by the Khomas region here in Namibia. It's on advanced subsidiary level, and this paper um, obviously it's 75 marks, and it mostly look at theme 2 within the AS level syllabus, right? As opposed to um, or rather, as you are preparing for the upcoming finals, I think this was also a very good initiative. If you go through this, it will obviously help if you have a copy of the question paper, and well, you can definitely get it on my classroom, Google Classroom. I'll In order for you to be able to download it. Right. I think there is one more important um, information that you probably have to take into consideration. You have a list of formula and notations on page 17 that you should definitely, if just when you are not sure about a formula, then you can just go and get it. And then also you have to take note of the second last um, bullet point here that says that if the degree of accuracy is not specified in the question and the answer is not exact, then you are supposed to give your answers correct to three significant figures. However, when you're now dealing with the angles or degrees, if it's angles in degrees, you give to one decimal place, but if it's in radians, you follow three significant figures unless otherwise stated. Now, another thing, because there's a lot of trigonometry and angles that you're going to calculate, whether it's the trapezium rule and so on, your calculator will be set back and forth to radian mode as well as degree mode. So you just have to make sure that you synchronize as you get to the questions. Right, let's see what the first question is all about. So they give you a polynomial p of x is defined by p of x is equal to 9x cubed plus 18x squared plus 5x plus 4. Then they say find the quotient when you are dividing p of x by 3x plus 2, and then you're supposed to show that there is a remainder. Now, you look at the mark allocation, this is 3 marks. You can obviously use long division, all right, in order for you to calculate this, but I'm going to use synthetic division, all right, just because I want to explain something. So when it comes to synthetic division, so let's say we take the 3x plus 2, so that equals to 0. If you have to solve here for x, you'll see that x will be negative 2 divided by 3. All right. Now, the idea here is maybe just so that I can explain to you what is it that I'm doing. So when I'm looking at 9x cubed plus 18x squared plus 5x plus 4, and I divide that with 3x plus 2. Now, you know that from synthetic division, the coefficient here should be 1. So what I will do is I'll divide throughout by 3. Okay, every term I'll divide by 3. And that will help me to find the coefficients that I need. So this is going to be 3 into that gives you obviously 3x cubed. Then you have 6x squared. Then you have 5 over 3x. And then you have 4 over 3. All right. And when you're now dividing this, you're going to have x plus 2 over 3. Can you see that when you now make that equals to 0 in synthetic division, right, you are going to have this negative 2 over 3. Okay, if you let that equal to 0, moving that whole thing over that side. Right, there are many ways you can do this. So I'm just going to go ahead and I'm going to write the coefficients, all right, the coefficients of this, and then they are in order descending powers of 3 of x, so everything is fine. And we're gonna obviously start off by making ourselves perhaps something like so. Let's just write in the coefficient. So I have 3 here, I have 6 here, I have 5 over 3 here, I have 4 over 3 here. Then you're going to have a little box here for your remainder, okay? And then on this side, you're going to obviously have your negative 2/3 here. That's what you're going to do, all right? Coming obviously from x plus 2 over 3 equals to 0, and then x equals to negative 2 over 3. Right. The first thing you do is you bring down this 3. So that is 3. Then you multiply these two together. And if you multiply negative 2/3 times 3, you're going to get negative 2 as an answer. And then you add 6 minus 4, that is obviously 6 minus 2 rather, that is 4. And then you go again, you multiply this with that. So in this direction, you multiply. So you multiply this with that. That gives you this answer. You multiply the same thing with 4. That will give you another answer over here. All right. So when you multiply that with 4, that's going to give you negative 8 over 3. Okay. And when you add this, you're going to get negative 1, for example. Again, you multiply negative 2 over 3 times negative 1. Of course, that's just going to give you positive 2 over 3. Once you add this to, you're going to get a remainder of 6. Now, where are we at? We're at the powers of x, the highest powers cube. So now your answer is going to be 1 less. So you have got 3x squared plus 4x minus, let's just write that 4x nicely, plus 4x minus x, and then you have a remainder of, in fact, I just have to come back to this one. I don't think the remainder is 6 though, right? Just grab the calculator and see. So you take 4 upon 3 and you add 2 upon 3. I think that gives you a remainder of 2. All right, good. So that remainder is 2. So that 2, I'm going to put it over, all right, over this x plus 2 over 3. Right. Now, one of the things that we don't like is that we don't like this complex fraction that is happening over here. Okay. So one way of then doing it is just cleverly say, okay, let me just multiply, you know, here by 3, and also I'm going to multiply on top by 3. And if you do that, you're going to have, at the end of the day, you have 3x squared plus 4x minus, not x rather, okay, this is something else. It's supposed to be minus 1. So it's minus 1. Okay, there we go. We corrected it. Now we are going to have 6 all over. If you multiply out, you're going to have 3x plus 2. That's what you're going to have. But you will get the same answer with synthetic division. I just wanted to show you where are you getting this idea where you are using I mean, when you do long division, you're going to get the same answer. But when you use synthetic division, you know, since you want to balance this so that it can be x plus a number or x minus a number, that's why I divided by that coefficient. Or you can go ahead and divide like normal without, you know, dividing every term by 3. You will be doing your synthetic division. And what you're going to get here, this is going to give you the remainder of 6. But then what you're going to get here, you will then have to take that and divide that answer by 3. And that eventually will give you this. So you can compare, you know, the past question papers that I've done for you to be able to see that. So as a matter of principle, don't waste too much time. You can obviously look at this question. If you are comfortable with long division, you can do long division, and it's going to give you exactly the answer with the remainder as required. But put the remainder over the divisor like that. Right, let's go to the B part, this is an extension. So it now says, hence, you are supposed to find the integral of p of x divided by that, but we already now have divided the polynomial, and this answer that is over here is going to be the answer that we are going to write. So we're going to have 3x squared plus 4x minus 1 plus that 6 upon 3x plus 2 is more than a couple of terms. So go ahead and put them in brackets, integrate that with respect to x, obviously from 0 up to 2. So this is a definite integral that we are supposed to calculate. Hopefully you know how to integrate the second part. You know, you can separate them, but I'm trusting that at this stage you are quite familiar with integrating that. Okay, so we are going to have 3x, to add 1 to the power, remember, so that's going to be 3x cubed over that same power plus 4x squared, because that power is 1, so add 1, over 2 minus x, because that's like x to the power of 0. Okay, then you have here something you need to be very careful. I'm just going to change the color. So I'm going to have plus 6 times 1 over 3, and then obviously the natural log of 3x plus 2. No need to put this in absolute value, because you know you have from 0 to 2, and if you punch in anything in there, in any case, it's going to be a positive value. Right, so hopefully the second part you still remember your rule. If you were to integrate a value like let's say 1 over, okay, like in this particular case you take 6, let's say we take that constant k, whatever that constant is, over ax plus b with respect to that, then you know that you can actually take out that constant, and you have that. So when you see that is where the 6 is, and now when you integrate that, you know that it's going to be k, then you multiply that by 1 over a times the natural log of ax, the natural log of ax plus b, obviously plus the constant of integration. So that is one of the general rules that you're supposed to know, and that is what you're seeing happening over here. Okay, right. So let's just go ahead and just clean this up so that you can evaluate what that integral would be. So on this side, I'm going to get, if I clean this up, this is going to give me x cubed. This is going to give me 2x squared minus x, and you have 6 times a third. That is going to be positive 2 times the natural log of 3x plus 2, and obviously we're going to take from the limits of 0 up to 2. So we can actually go ahead and implement or input the values. The x starting with the upper limit, that is 2 cubed plus 2 times 2 squared minus 2 plus 2 times the natural log of 3 times 2 plus 2. Okay, all of this we're going to subtract with the same thing. Now take the lower limit at 0 cubed plus 2 times 0, where we have an x, you're not going to substitute, minus 0 plus 2 times the natural log of 3 times 0 plus 2. One of the things you should never assume is that this second answer is definitely a 0. So do not assume that. Okay. So we started with the upper limit and then the lower limit. So once you do that, and you can grab your calculator, you're going to have 14 over here plus 2 times the natural log. This business over here gives you 8. All right. Then once you have everything here is going to be 0, but you have a negative times a positive, give you this negative that you have times the natural log of 2. That is what I have over here, but there's a 2 in front, so it's 2 natural log of 2. Okay. Now the second part of it, now it's very important. You see how they want you to give your answer. They want you to give your answer in this form, a being a number, and then the natural log of b. So let's then see, and hopefully you to remember that this is going to be like your a value, which in this case is 14. All right, and then this is obviously um, you can write this as 10 plus the natural log of 8 squared minus the natural log of 2 squared, and then this part becomes 14, and then you have plus the 8 squared natural log of 8 over 2, all of that squared, eventually giving you the answer of 14 plus the natural log of 16, because you get half of 8, which is 4, and 4 squared is 16. And this answer is the answer that we are looking for at the end of the day. Okay, and it's supposed to be in that form. One of the things is you'll probably see me adding more pages because it could be like the spaces are not enough, right? They wanted it as a plus natural log of b. A is 14 and your b is 16. That is the required result. All right, let's look at the second question. The question deals with the function of h, and it's defined as h of x is equal to the natural log of the quantity x minus 3, and the domain is from x is greater than 3, or greater than a, where a is a constant. Now, you know that from laws of logs that you can't have this value over here should be a value that is greater than 0. And that gives you that x will be greater than 3. Therefore, a is equal to 3. That is what you are required to do. Values that are greater than 3 will make this to be able to exist. Right. Then they say find the for this value of a, right? So now for that value of a, find the expression for the inverse of that function. So what I'll do is they want you to find the inverse. So I'm just going to write this function as, remember, it is given as h of x is equal to the natural log of x minus 3, there's 2 marks, and I'm going to rewrite that as y equals to the natural log of x minus 3. Then you switch the letters around, you have got x equals to the natural log of y minus 3. So the idea here is to make y the subject of the formula. So I hope you understand that the natural log is nothing but log base e, that's what it is, okay? And I'm going to write it in the exponential form. So that means e raised to the power of x. So that is e raised to the power of x is going to equal to y minus 3, so making y the subject of the formula. This gives you that y is equal to e raised to the power of x plus 3. But remember, we're not looking for y, we're looking for the inverse. So this was just a method that we used. All right. So our solution then is going to be the inverse of h is equal to e to the x plus 3. That is what we are looking for in our solution. Okay. Right. Now they will probably ask you to sketch these two functions. Now, one of the things you should realize when you're dealing with this, the original function here, you see that we said that it should be greater than 3. So we are going to draw, I'm going to draw the line x equals to 3, but I'm going to do that as a dotted line. So as a dotted line x equals to 3, let's suppose, because of the way my graph is, let's suppose that dotted line is over here. That is, let's say, up to there. I don't want to continue. So let's say that is the line x equals to 3. So this here, let's suppose this is the line x equals to 3. When you now look at your function, and that function was um, h of x was that equal to the natural log of x minus 3. So this is like y equals to the natural log of x minus 3. At this level, I hope you know that the type of way the function is. I want to know where this function will cut the x-axis. Okay, where will it cut the x-axis? It will cut the x-axis at the point where y equals to 0. So when you have y equals to 0, and if you were to solve, remember this is just nothing but log base e, so I can actually take it off. Where you see the natural log, I'm going to replace it with log base e. It's the same thing. So this then can give you that e raised to the power of 0. If you were to rewrite it, this is going to be e raised to the power of 0 is equal to x minus 3. This eventually will be the same as 1 equals to x minus 3. Therefore, x is equal to 4 if you were to do that. This is where it's going to intercept. So the way that that function is, it cannot pass this because it has an asymptote here, but it will keep on going in this direction, right? So something like so. This is h of x, and the point here is the point 4 or 4 comma 0, and that's very important. So this is my h of x. Then you just do the same for the inverse. The inverse here, the asymptote is x equals to 3. On the y-axis, this thing's just going to be reversing. So if I was to say, can perhaps change the color. If I was to do that, let's suppose this is the line, and I just end there. So this is going to be the line of y equals 2. This is the line y equals to 3. So it's just going to be the opposite. So this is the line y equals to 3. So here, this h of x is cutting the x at 4. And our other one, the inverse, will cut the y-axis at 4. So this is the point 4 here. So you just switch. Can you see that? You just switch. So the green one that you see over here is the inverse. So very important to show where the asymptotes are. And I didn't want to go too much with that asymptote so it doesn't, interfere with the other graphs. But that is technically what is it that we were looking for. Okay, right. There's obviously the identity line of y equals to x that you can draw, and that line is a line of it's a line of reflection, basically, if you had to draw that. So that is also another line that can guide you in how to draw functions and their inverses. Right. So once you know what is the x-intercept, and then you just switch, it's going to be the y for the other one. The asymptote is x equals to 3 because its values should be greater than 3, remember, in order for that natural log function to be able to exist. Okay, let's look at question number 3. Now, question number 3 says, showing all necessary workings of the equation. Now, I hope you are very familiar with your reciprocal functions, okay? And then you know that the sec is the same as 1 over cos. So sec is the same as 1 over cos of alpha. And multiply that with cosec is the same as 1 over sine of alpha. And that should equal to 7. Right, let's just combine them because they can be written everything over the same, because 1 times 1 is 1. And then here I have cos alpha sine alpha, and that equals to 7. I can go ahead and put that 7 over 1 if I want to. So what this means is that if I take a reciprocal of both sides, I'm going to have cos alpha sine alpha, and this is equal to 1 over 7. Okay. Now, before I continue, I just want to, and this is in your formula sheet, right? And I hope that you know that from your formula sheet, if you have double angle of sine 2a, this is actually the same as 2 sine a cos a, and you will find this within your formula sheet. I have cos, so can you see that? I need to get rid of this 2. So if I divide throughout by 2, right? If I divide here by 2 and I divide here by 2, dividing by 2 over here by 2 over here, this means that in this case sine alpha cos alpha is identical to sine the double angle that over 2, which is essentially what this is. This is exactly that. It's just that in terms of a. So I'm going to replace this yellow part. I'm going to replace it with this over here. Okay. So that is now going to be written as this whole thing, but I'm not going to use a. I'm going to use alpha. It's sine of 2 alpha. Okay, divided by 2 is equal to 1 over 7. Right. Now, isolate that sine 2 alpha. Right. So this is sine of 2 alpha is equal to times 2 everywhere. So you have 2 over 7. Now, I would like to calculate what we call the key angle. Okay. So our key angle, and the domain is given to us in degrees, so your calculator has to be set to degrees. All right. Our key angle is going to be the inverse sine of 2 over 7. And if you were to calculate this, okay, my calculator is in a radian mode, so let's just make sure we get it in degrees mode, and that is the inverse sine of 2 upon 7. Right, if you hit equal to, you get 16 point, capture that, or take that, a screen. All right, so that is what this is. However, we have to consider a new domain, because our answer is just not in the first quadrant. You have to be a bit careful. Our domain is sine 2a, so our new domain, so to speak, our new domain, this will tell us exactly the number of solutions, is going to be 2 alpha, and you multiply then each one of those terms, the 90 times 2, which is 180 degrees. And sine is positive, because this ratio is positive, in the first as well as in the second quadrant. So one of the solutions would be, let's say in the first quadrant, you're going to say that 2 alpha, you say 2 alpha is equal to 16.6015 and so on and so on degrees. Okay. In the second quadrant, 2 alpha will equal to, remember the second quadrant from your cos diagram, if you have your cos diagram, right, and you have your angle like so, let's suppose that is the angle, then one angle will obviously be here, what is in the first quadrant, and the other angle will be the angle all the way up to there, which is essentially 180 minus our reference angle. You understand that? So in the second quadrant, we're going to say 180 degrees minus 16.6015, and essentially we're going to divide all of those answers then by 2. Okay, right. So in the first one, our answer therefore for alpha, ooh, that alpha looks very violent, answer will be, I'm just going to use my calculator and you can just follow. So I've got 16.05. I'm going to divide the answer by 2 to get alpha alone. Okay, so I'm going to divide by 2 So dividing by 2 and dividing by 2. So taking this answer, dividing it by 2, that should give you one of the solutions, which is 8.3 to 1 decimal place. So it is 8.3 degrees to 1 decimal place. Then doing the same over here, we are going to, whatever that answer is, we are going to divide that answer as well by 2, because we are looking for that particular value of alpha. So dividing here by 2 and so on, right? So if you have to take, okay, you have that 16, so I say 180 minus our answer, which gives you 163.3984. That is the difference between 180 minus that. And then I'm going to divide that answer by 2, and 81.7 is the other solution. Okay, 81.7 degrees. And those are the two solutions for alpha. Okay, those are the two solutions that we have for alpha. Just going to go ahead and put them in a box, right, so that you can know what our values are. So there was quite a lot, and this is very handy, and you needed to also remember that. Right, let's look at the B part. Now they say showing all necessary working. Solve the equation. Now I hope, again, as I said, you can go to your list of formula for you to know how you can write this. This over here is sine beta of cos 20 degrees, okay, plus cos beta sine of 20 degrees. That's what this one over here gives you. Then we're going to plus, this is going to be sine beta cos 20 degrees minus, okay, cos beta sine of 20 degrees. Now, obviously, all of this should equal to, and I'm running out of space, but remember in the exam you may not write in this margin. Okay. Now, let us see. If you look closely, you see this term here, the sine beta cos 20, sine beta cos 20, and this one here, sine beta cos 20. They are like terms, so that is 2 sine beta cos 20. Are we together so far? Then if you look at, and I'm going to make this one, if you look at cos beta sine 20 minus cos beta sine 20, they cancel each other. Okay, this and this one cancel each other. So at the end of the day, we are left with 2 sine beta cos of 20, and then we say that is equal to 6 cos beta. All right, there we go. So again, I'll remind you that if you have sine of A plus B, this is actually going to be sine A cos B plus sine remains the same, cos A sine B. Right. Again, this is something that you can find in your formula sheet, and that is what I was applying there. Okay. Right. It's totally up to you. What is your next step going to be? I'm going to be dividing throughout by cos B. I'm going to divide here by cos B. And I'm going to divide here by cos B. And the reason I'm doing that, excuse me, is because you can see that sine B over cos B becomes the tangent. Okay, so this is going to be 2 the tangent of beta. Multiply that by cos of 20 degrees, which is a value, which is a number, and that should equal to 6 because cos B here, they do cancel. All right, so the cos B here cancel there, and this gives you the tangent. Right, in any case then, if we then have to get that 2 tan B first alone, I have 2 tan beta is equal to 6 all over divided by cos of 20 degrees, which is a value that exists. Right, the next thing is to get rid of these 2, and you divide throughout by 2. This will leave you with tan beta is equal to, if you divide by 2, 2 goes into 6, that gives you 3 over cos of 20 degrees, which is a value that you can find within your calculator. And here, once you have so much working that you need to do, they will not make the domain so complicated for you. So whatever our B is tangent, it should be in the first quadrant. Okay, so that means one solution. All right. Then, and again, it's in degrees mode, so make sure your calculator as well is in degrees mode. So I'm going to say that beta is equal to, okay, that beta, oh, that beta looks horrible. I'm going to say that beta is equal to the inverse tangent of 3 over cos of 20 degrees, okay? And that is going to tell me what this is. So let's grab our calculator. Our calculator is in degrees mode already, so there's nothing to be afraid of. So we take the inverse tangent of 3 over cosine of 20 degrees. Okay, and then you hit equal to, and this is our solution. So just one solution to this answer over here. Right, so the answer we are looking for, therefore, beta is equal to 72, I believe. Oh, I see, I made a mistake, right? This, I put a 2 here. So let's go back. Let's go back to our calculator. See, nice thing about having that. So let's go back to our calculator. I put a 2 there. So just go back and say 20. Okay, right. That is the answer I'm looking for. Let's take that. Right. So it's possible to also write something wrongly or to type in something wrongly on the calculator. So you can always just refer back. So this is 72.6, and you're supposed to give your answers in degrees to 1 decimal place, and that is the correct answer that we are looking for. Okay, and that is what our essentially what our beta is. Good. For 4 marks. So again, you should definitely know your compound angles and how you use that in order to solve the values and then get to this answer. Right, now question 4, and I'm trying to not rush through them, but it is a long question paper. It takes you about 2 hours to complete when you write it in the exam. They say an equation has a curve, or a curve has an equation of y equals to 3 plus 2 the natural log of x upon 1 plus the natural log of x. Find the exact gradient. The key word here is exact, so you should not give decimal solutions and stuff like that. Alright, you have to write something in terms of something, perhaps, in terms of the natural log or whatever the case may be. And they say at the point for which, and this is also another light bulb moment. Normally, if you calculate the gradient in terms of x, they give you the value of x. So you'll definitely need to know what is the corresponding value of x. So before I do any, because when you want to find the exact gradient, you're supposed to substitute the x value into your derivative, okay, for you to be able to say what is our gradient going to be. So let me find x. First of all, finding x when y is equal to 4 in this equation, all right, in the equation. So I know I'll have to differentiate that, no problem, but let me find x so that once I work out my derivative, then I would be able to substitute in my derivative function. I'll be able to substitute my value of x, because that is essentially what I'm looking for. Okay, right. So let's just also, whatever value of y I'm going to get, because I have the natural logs here, I'm going to probably leave my answer in terms of e. I'm going to get an exact value. So this is then 3 plus, taking the function, 2 times the natural log of x all over 1 plus the natural log of x, and this should equal to 4. So go ahead and put this in brackets. So at the end of the day, this is 4 times 1 plus the natural log of x is equal to 3 plus 2 times the natural log of x. So this is 4 plus 4 times the natural log of x is equal to 3 plus 2 times the natural log of x. Okay. Then at the end of the day, if I have to consider the like terms, I have got 4, the natural log of x, minus 2, the natural log of x, and that equals to 3, take away 4 if you take the numbers together. This is leaving you with 2 times the natural log of x, because like coefficient, think of this natural log of x as an operator, okay? And this is giving you -1, so to speak. Right. So another thing then, if you have to go and just clean it up a bit, this will give you that the natural log of x is equal to -1/2. So again, I keep on telling you this, and then you have to know it, but I'm going to write it anyway. The natural log of x is nothing but log base e. It means the same thing, right? So what I'm going to do then is I'm going to then, change it from log form to exponential form. So that's e raised to the -1/2 power. So this is my value of e, of x. Our x value is equal to this, and this is the x value that I'm going to input in my dy dx. So if I have to find the derivative, when I do dy dx of this function, I'm going to find what the gradient is at the point where x is equal to e raised to the -1/2 power. E raised to the -1/2 power. That is why we had to find it. So naturally, sometimes they give you already the value of x, but in this particular case, they gave you the y value. So there's a little bit more work that needs to be done. Right, so let us take that function and let's find its derivative. And you'll see that you are having a function divided by another function. So that means we'll be using the quotient rule here. Okay, so I'm gonna start all the way up over here. So I want to differentiate this function. So to find the derivative here, you have d by dx of, and this is very key, right, in helping me, or I can just go ahead and just say dy dx, right? Don't have to use those notations. So I can say dy dx is going to equal to, now you can use, I'm going to use the quotient rule. Okay, the quotient rule, I hope I wrote quotient rule correctly, or you can use the product rule if you want to. It's totally up to you, but I'm going to use the quotient rule. Okay, right, the quotient rule, what does it say? It says take the denominator, that is 1 plus the natural log of x. Okay, that's low, d high. Then take the derivative of the numerator. So if you take the derivative of the numerator, the derivative of 3 is 0, the derivative of 2 natural log of x is nothing but 2 over x. Hopefully you still know that, okay? That if you take the derivative dy dx, or if, and I'm going to take it off here eventually, if you take d by dx of, let's say, the natural log of x, that it equals to nothing but 1 over x. So that is 2 here, so that becomes 2 times 1 over x, which is 2 over x. Very important that you remember that, little way how you find that. Right, let's then go and continue. So you write the denominator times the derivative of the numerator minus the numerator as it is. What is the numerator? Well, we're going to put it as 3 plus 2 times the natural log of x, and you're going to multiply that with the derivative of the denominator, which is derivative of 1 is 0, and the derivative of natural log of x, as I put it here, it's 1 over x. All of this you're going to put over the denominator all squared. That's 1 plus the natural log of x all squared. Right. That is how you will be doing this using that. So let's just clean up what we have, okay? And hopefully you will just follow. So I'm going to multiply this term here with 2 over x. So that is going to be 2 over x, right, plus 2 over x, natural log of x, follow. And then you have minus, so I'm going to multiply this. That's minus 3 over x, okay, this times 3, plus, okay, and this is very important that we understand this concept is I'm multiplying this over, yeah, I'm multiplying this over into that. This is one term, so I'm multiplying this into that, but there is a minus there. Since there is a minus, and it's important that you understand that, I'm going to put a bracket here, okay, because I'm multiplying, I'm distributing. So 1 over x times that is nothing but 2 over x, the natural log of x. Very important, because this negative sign will still be changing the stuff inside. All of this obviously over the denominator, that you do not expand the denominator. You leave it as it is, okay? That is 1 plus the natural log of x all squared. Right, I think we can still clean up the numerator. And if you do that, I'm going to have, and hopefully you follow, I'm going to have this 2 over x. And here, if you distribute, you're going to have minus 3 over x. Then I have plus 2 over x times the natural log of x. And this times that gives you minus 2 over x, the natural log of x. Effectively, you will see that those two terms at the end, they definitely cancel each other. So you have 1 plus the natural log of x all squared. Right. So as I said, this term and this term cancel. And then if you look at what you have over here, you have 2 minus 3, which is negative 1. That is like negative 1 over x. This should be divided by, perhaps I need to append a page because the space is not enough. Okay, the space is not enough. So let's do that. Let's append a page so we can work on further. All right. So what do I have? I said you have 2 minus 3, which was minus 1 over x. So you get minus 1 over x, right? That's what this numerator will give you over here, all over 1 plus natural log of x all squared, all over 1 plus the natural log of x all squared. So I'm just continuing from there. One of the things that you should know is that when you're dealing with a complex fraction like this, right, supposedly you have something like 2 over 3, let's say you divide it by 5, right? What you do for optics purposes, you will be multiplying by 3 on both sides. So what you're going to be left with is just going to be 2 over 15. And you can actually go ahead and see that that is exactly going to be the answer. If you have 2 over 3 and you divide that by 5, for example, that gives you this answer of 2 over 15. Now, the reason I did that was that I'm going to multiply here by x, and I'm also going to multiply here by x, okay? So eventually the x's cancel there, leaving me with negative 1 over, okay, that negative looks like it's social distancing from the answer that I'm looking for. Negative 1 over this x here, and in bracket 1 plus the natural log of x all squared. This is dy dx. Okay, Khomas region really had put some things in there. Kids really felt it. Now we are not done because it's a 5-mark question. We have the derivative. Remember what I said? We have to put the value of x that I calculated into the derivative function. And if you remember well, from what I did in the previous page, I had my value of x over here, where I said that we need to substitute that into the derivative. And this is now going to come in handy since I now know what is the derivative. So this e raised to the has to be substituted everywhere. Have an x, I'm going to substitute e raised to the power of negative a half. And it's also important that you understand that the answer should be exact. So you should, because e is an irrational number, and you're supposed to not write that natural number, right, raised to whatever. So our answer will probably also be in terms of e, since I have the natural log of x over here. So that means I'm just going to substitute everywhere into my derivative. Where I have an x now, I'm going to substitute it with this value here. Okay, so dy dx, when e is equal to that, when x is equal to that value, when x is equal to that value, this is going to give me negative 1 over, okay, 1 plus the natural log of, so we are now here going to put e raised to negative a half, okay, e raised to negative a half, e raised to negative a half. That's what we're going to do. At the end of the day, this cleans up, or we can actually clean this up. I'm going to leave my negative 1 on top for now. And this is very important that you understand. Work inside. So this is going to be e raised to negative a half, but here you have 1 plus, now that negative a half, so that is going to now make this a negative. So it's going to be negative 1 half, okay, times the natural log of e, all squared. And one more thing that you need to understand and know, you should know that the natural log of e is equal to 1. All right? So this over here becomes just 1. So at the end of the day, this will leave me with, okay, the negative 1 raised to e raised to the power of negative a half. And inside, you're going to have 1 minus a half squared, since this is just 1. Eventually, this is going to give you negative 1 all over e raised to the power of negative a half. I'm doing it step by step so that hopefully you can understand. You're going to have a half all squared here. Right. Now, everything is going to be to the negative power. So basically, you have negative 1 and you have e raised to the power of, yeah, you have e raised to the power of negative half, and this is also 2 raised to the power of negative 2. That's what this one can be written as. And e raised to the power of what? Negative a half. Bottom line, when you are dealing with stuff like that, yeah, then they're going to come on top there. So eventually, because the way I wrote, I probably have to insert another page. Okay. Eventually, all this becomes positive, so this becomes negative 1 on top. Then it's going to be 2 squared e raised to the power of a half power as they go, as you now put those values on top there. Okay. It's going to give you negative 4 e raised to the power of a half. And this is the exact answer that they required. And that is why I said this was quite a challenging function. I don't know if the learners did not struggle with it, but if you were attempting it and you were wondering how to get to that, I tried to show you step by step and also work a bit slow so that at least you get it. Right. You see, all of that work, you have to take all of the things into consideration whenever you are solving this particular question. Right. Now, let's go to the very next question. The equation of a curve is x squared minus 4xy minus 2y squared minus is equal to 1. This is, you're supposed to show the derivative. That means this is implicit differentiation. And by now, if you have got problems, you obviously can follow my videos onto the channel for you to see how you will be doing implicit differentiation. I'm just going to write it down here again. Here, when I differentiate, I'm going to use the product rule. So this is going to be very handy, the product rule. Again, the product rule is attached to your formula sheet. So this is like d by dx of everything here, x squared minus 4xy minus 2y squared, and that should be equal to dy dx of 1. And the derivative of 1 is going to equal to 0. So we're going to differentiate each term as we normally do. So this here, take 2 times, you reduce the power, minus, now here we are going to use the product rule. What does the product rule say? The product rule says, so this is 2x, not square, 2x. Let's save this because I can already see things are happening there. So the product will say 2x, here, keep the first, so minus 4x, take the derivative of y, and the derivative of y is just 1, but then because it's different, you're deriving y, you are supposed to differentiate with respect to x, so you have to put dy dx here. Everywhere we're now doing the y's. Alright? Then plus, keep the second, that is y, keep y, you multiply that with the derivative of the first. What is the derivative of minus 4x? It's just going to be minus 4. Then minus the derivative of this is going to be 4y, but this is to respect to y, so you have to put dy dx. And this is equal to 0 because the derivative of 1 is equal to 0. Now what we're going to do is we're going to write all the terms, or let me just clean this up a little bit. So that is 2x minus 4x dy dx plus, or minus 4 rather, minus 4y minus 4y again, but this one has got dy dx is equal to 0. So we are looking for dy dx. So at the end of the day, if you look at what you have, I'm going to write those coefficients. I have 2x minus 4y. Okay, that's what I have. And this is going to equal to, so I'm going to take all these ones that have got a dy dx over to the other side. It's going to be, you can actually add them. It's going to be minus 4x, so it becomes plus 4x. So it's just going to be 4x again. So this is 4x dy dx again plus 4y dy dx. Right. Probably have to introduce more space there for you to be able to see where I'm going with it. But most probably I can do it over here, and I'll just do it with a different color pen. So at the end of the day, this one's over here, you just write whatever you have. You've got 4x plus 4y, all right? And that is the same as saying 4x plus 4y. I like to put my dy dx behind, so that's dy dx is equal to 2x minus 4y. So when you are now trying to show what dy dx is, it will be that 2x minus 4x is 2x minus 4y rather. This is 2x minus 4y, this one, all right? So this one also, it's going to be 2x minus 4y, that divided by this whole 4x plus 4y. If I'm not mistaken, this was what they wanted us to prove, and we're just going to go back there and see whether indeed that was the case. All right. You can see it's all over here. So I wanted to save, but let's see if I grab a snapshot of this. And if I, here we go. Okay. Don't worry, we are going to continue. Let me just go back and see where is it that this paper is. It's the Khomas paper. and we are doing paper 2. Okay, you must be on the standby. I'm going to do paper 1 very soon as well. In fact, it's not going to be the only paper 1s that I'm going to do. I'm going to do the national ones as well, and I'm going to stand by for that tomorrow. Okay, right. Right, I just had to bring this in so you can see this is what they wanted us to show, and eventually I did that. Now, when you look at part B, it says show for 3 marks, show that the curve has no stationary point. When the curve has no stationary point, at stationary point, what happens at stationary point? At stationary point, dy dx is equal to 0. That's one of the things, all right? So I'm just going to write that down here. At stationary points, dy dx is equal to 0. Whenever you have to do that, you have to look at the numerator. The numerator, you let the numerator equal to 0. Or you can take this whole dy dx and let it equal to 0. You are going to be left with 2x minus 4y is equal to 0. Because the numerator, rather, as I said, right? You're going to have that. So I'm going to make x the subject of the formula. And I want to substitute that in. So let me just write nicely so I can make use of my space nicely. That is 2x is equal to 4y, and then x is going to be equal to 2y. Okay, what does it mean? Show that the curve has no stationary point. So we expect something that will not be able to have roots. This x equals to negative 2y. I'm going to substitute it into the original equation in order for me to see what is going to be the possible outcome. So looking at the original equation, which is over here, everywhere where I have, oh my goodness, you just have to bear with me. It seems to me like this is acting up today, and hopefully it's restoring. I think it's a little bit overloaded, but let's restore. Let's see. Yeah, this is where I am. So I want to substitute that x value everywhere where I have x. I'm going to substitute that for 2y for x in order for me to see what is going to be the equation. So this is going to be 2y squared in the place of x minus 4 times 2y times y minus 2y squared is equal to 1. This is giving me nothing but 4y squared minus this, all this business giving me 8y squared, okay, minus 2y squared is equal to 1. If you clean this up over here, you get negative 6y squared is equal to 1. If you were to calculate y squared, for example, you will have negative 1 over 6, and you can't take the square root of negative 1 over 6. So there are no real roots, no real solutions. So the curve has no stationary point. Okay? There's no stationary point. That's how you will be doing that. All right, let's continue. Find the exact find the x coordinate of each of the points on the curve at which the tangent is parallel to the y-axis. Now, I want you to think of that for a moment. When the tangent is parallel to the y-axis, what type of line is that? Well, that is going to be a vertical line. And vertical line, their gradients is undefined. So when you have dy dx, or when you are doing the gradient, you're going to take the numerator, and you take the numerator, is it? Not the numerator, but the denominator. You're going to take the denominator, because the denominator, right, from from your work on delta y over delta x, the only condition when you are working with gradients, when you have something like this, is if you have that for some reason you have some value here and here you have 0. This is undefined, and this type of lines, vertical lines are undefined. So in order for me to do this, I'm going to take the denominator of dy dx and let the denominator equal to 0. Let that denominator equal to 0. So what was the denominator of dy dx? The denominator of dy dx was 4x plus 4y. 4x plus 4y. So I'm going to let that equals to 0. Okay, so take 4x plus 4y, let that equal to 0. And I'm going to make y the subject of the formula, and you will realize that y is equal to negative x. If you do that, you're going to substitute this into the curve, because it says find the x-coordinate of each of the points on the curve. So you're going to substitute this into the curve. It most probably means that you are going to have two solutions. Now, remember what was our curve? This was our curve. So we're going to substitute this into the curve for us in order to see what we are getting. So I'm writing it here so I can save some space, right? So we are going to have, everywhere we have an x, or where we have a y rather, I'm going to substitute the value of minus x where I have a y and see what is it that I get. Right, so this is going to be x square minus 4x, and in bracket minus 2 in bracket is equal to 1. So in bracket we are going to substitute negative x for y, negative x for y. This cleans up to, if you have to work it out with me, x squared plus 4x squared, okay, minus, because that is x squared, minus 2x squared is equal to 1. This is 5 minus 2, that is 3x squared is equal to 1. Okay. If you have to work this one out, you realize that x squared is equal to 1 over 3, and therefore x is equal to positive negative square root of 1 over 3, which is the answer. Or, since they didn't specify that you must give the exact answer, you can actually go ahead and give, solutions like this will also be acceptable. You can say it's going to be plus or minus whatever is the square root of 1 over 3. So if you take this square root of 1 over 3, you're going to have probably root 3 over 3. So 0.577 plus minus 0.577. This is also going to be an acceptable answer to values of x. Anyway, any one of them will do. Alright, that brings me to question 6 of the question paper. It says the variables x and y satisfy the equation a raised to the 2y is equal to e raised to the 3x plus k, where a and k are constants. The graph of y against x is a straight line. Use logarithms to show that the gradient of the line is equal to this value. So we're going to try to write this in the form y equals to mx plus c. So because I have an e here, I'm going to take the natural log of both sides. So that's the natural log of a to the 2y is equal to the natural log of e to the 3x plus k. Okay, then I'm going to have 2y times the natural log of a is equal to 3x plus k, and then obviously you have the natural log of e, which definitely becomes redundant because it's just 1. So you have 2y natural log of a is equal to 3x plus k. The idea is, as I said, to write it in the form y equals to mx plus c. So first I'm going to divide throughout by the natural log of a. So I have 2y is equal to 3 divided by the natural log of a, x here, plus k divided by the natural log of a. But there's that 2 there, so I'll be dividing every term by 2 as well. And if I do that, I'm going to end up with y equals to 3 over 2 natural log of a of x plus k over 2 natural log of a. What is the gradient? This is the gradient, y equals mx plus c. And that is what we're supposed to show, and we have that. Okay. Now they are saying, given that the straight line passes through these points, as you can see, find the values of a and the value of k. Now, first thing that I'm going to do is let me calculate what the gradient is from this. So I take the two y values and I subtract them from each other. So I'm going to take 3.80 minus 0.95 all over 3.3 minus 0.4. Use your calculator. This is going to give me 57 over 58. Okay. Then, what do I now know? I know that the gradient, which is the m value, is equal to this. So I can therefore say 3 over 2 natural log of a should equal to 57 over 58. This one is going to allow me to find the natural log of a. And what I will do is I'll first get rid of this natural log of a. I'm going to have 3 over 2 equals to 57 over 58 times the natural log of a. So of course multiply that into that. Then the natural log of a eventually will be, the natural log of a will be this 3 over 2 times 58 over 57. You see I'm multiplying that with the inverse. So eventually it gives me that the natural log of a is equal to 29 over 19. 29 over 19. Okay. I can now calculate the value of a. Remember, natural log of a is just log base e. So this is log base e of a, right? So what I will do, I'll just say that a equals to e raised to the 29 over 19th power. Okay, so I'm not going to have my decimal equivalents and stuff like that. Then that allowed me to find the value of a. So I'm now going to see if I can find the value of k. Just going to separate this work. Right, how am I going to find the values of k? Let me just save this. I'm going to find the value of k by saying my formula. Remember my formula now. My formula is in the form, it's in the form y equals to mx plus c. I'm going to take one point, and perhaps I will take this point. Doesn't matter, any one of the points, okay? For y, I'm going to substitute 0.95. My gradient, I already know. My gradient is 57 over 58. That is my gradient. My gradient is 57 over 58. The x value is 0.4, okay? And what is my c value? Well, my c value is all of this value over here. This is my c value, which is nothing but, let me just write it in with black, it's nothing but k over 2 times the natural log. But now, here's the thing, we know what a is. A was e raised to the power of 29 over 19 from here. So we have to do all of this multiplication in order for us to find that k value eventually. Right, so what I'm going to do, I'm going to grab my calculator. I'm going to say 0.95, which is this one here, should be because this is a term that is positive, I'm going to bring the whole of this term over by subtracting 57 over 58, which is supposed to be multiplied by 0.4. Okay, so this answer is going to be 323 over 580. So that's 323 over 580, and that's going to equal to k over 2 times the natural log of e raised to 29 over 19th. I'm just going to clean this up in a bit. Okay, make sure we are at the correct answer. Now I'm just going to go step by step. This is 323 over 580, and this is equal to k over 2 times 29 over 19, because if I bring that 29 over 19 using the power law, the natural log of e is just equal to 1. Okay, so far so good. Then if you were to calculate this value of k, I'm just going to write it here so I can have space. K, this is going to equal to 2 times that, which is 58 over 19. This whole thing can be written as 323 over 580 equals to 19 over 58k, because if you have this, remember what I said, you multiply by 19, multiply by 19. Okay, so now I can find my k value, and k is going to be 323 over 580 should multiply by the inverse 58 over 19. And if you do so, you are going to get an answer times 58 over 19. What do we get? 17 over 10. 1.7. 17 over 10. So these are then the solutions that we have. K is equal to all of that, and then as well as A is equal to all of that. I know it's a handful. Again, as I said, Khomas really knew how to go and find these functions. It's interesting questions. Okay, right. Let's go to question 7, the harmonic or the R formula, and they say express that 5 root 3 times the cos of x plus 5 sine x in terms of r cos of x minus alpha, where alpha is an angle that is between 0 and half pi radians. It means your calculator should be set in radian mode. At this level, I do expect that you should know that you can calculate the value of r, right, by taking 5 times the square root of 3 plus 5. This I expect you to be able to do. Okay, if you punch this, you're going to get a square root of 100, which is 10. So my r is equal to 10. And I just want to bring in what this one here is. You know what r is, but cos of x minus alpha can be written as cos x cos alpha plus the opposite, right? Cos, is it? Plus, very important. What do we have? Plus sine x sine alpha. If I clean this up, this is going to be, so the cos of x minus alpha, this is going to be, if I write cos alpha here and cos x here plus sine alpha here and sine x over here. The reason why I want to compare this with something over there and that one also. So I'm going to rewrite this part as 5 square root of 3 cos x plus, what is it, 5 sine x. So at the end of the day, equating the coefficients, if you look at the coefficients, you will know that the coefficients, okay, this cos x and cos x, these are okay. So I'm just going to look at, what did you have? You have cos x is equal to, not cos x but cos alpha. Cos alpha is equal to 5 root 3. And what do you have? You have sin alpha here is equal to 5. Now you know you're supposed to use the tangent. So the tangent of alpha is sine over cos. So you put the 5 on top of the 5 root 3. So that eventually alpha is going to equal to the inverse tangent of all of this, which is 5 over 5 root 3, and alpha will be a, let's calculate it and make sure our calculator is in degrees mode. So we are finding the inverse tangent of 5 over 5 root 3. Okay, so it's 30 degrees. I'm even saying degrees. We are supposed to have it in radians. 30 degrees, if you know, 30 degrees is pi over 6 radians. Okay, it's pi over 6 radians. Okay, pi over 6 radians. Right, so alpha is pi over 6 radians. Right, I don't really have a lot of space there, but the way that you are supposed to write this answer, you are supposed to write the answer and say, therefore, 5 root 3 cos x plus 5 sine x, right, is equal to 10, which was r, and in bracket, I mean cosine of x minus pi over 6. That is how you are actually supposed to write that answer, the final one. Okay, that is how you're supposed to write it. But I guess that in this particular case, as long as they see you got the value of r, as long as you see you got the value of alpha, but they said express it in that form. Very important. Right. Part B, as x varies, find the least possible value of that. So let us first do that first part, because this question has two parts. They want us to find the least possible value. Now, what is it that we know? We know that this part of this expression is exactly, so this is 4 plus the part that I highlighted is actually 10 cos of x minus pi over 6. That's what it is. You with me? Now, here is something that you should know about the cosine graph. So if you have the cosine graph, okay, looks weird, but I think you get the idea. The cosine graph, obviously, it oscillates, okay, and then it goes down, so. And our pi over 2 will be here. So at the end of the day, let's just extend this and extend this. Okay. This is obviously going to be, again, as I said, I want to take my time. So this is going to be the y-axis, and that is going to be the x-axis. That's 0 here. That is pi over 2, and that's pi. This here is pi, and this is going to be negative pi, and it goes between 1 and negative 1. So when you are at that, you get negative 1. Does that make sense? Right. So the least value of the graph will be at negative 1. So regardless of what this angle is, this part of, if we are interested in this part of the function, if you were to graph this part of the function, right, you can see that it's going to be, the least part will be going to be where? At negative 1. That's the least part. If it was greater or whatever, it will be positive 1. Right. So this now implies that this can actually be written as 4 plus 10, and this part of the graph is actually at negative 1, because that's what it is, the least part of it. So at the end of the day, I've got 4 minus 10, which gives you negative 6. And negative 6 will be the least value. Now they are also saying the second part, determine the corresponding value of x. So this becomes now an equation. What do we know? And because it's a conjunction, so I know that cos of x minus pi over 6, which is the least, which is going to be a negative 1. What are going to be the x? What are going to be the x values there? Okay, that's what I want to do. Now, I don't need to use a special whatever calculator or something like this. You know that the inverse cosine of negative 1 is going to be negative pi, I believe. Okay, can you see that? So this is x minus pi over 6 is equal to negative pi, as I was saying that. Right, this implies that, of course, if you were to use your calculator, you say the inverse cosine of negative 1, okay, it takes it as pi, but you know that we are now looking at ways that it's negative 1 is going to take place where? At negative pi. And that makes sense to you. All right. That is essentially what we're looking for. Also, it depends on the quadrant, because as you can see, that hopefully you know that this is negative 1 and cosine. If this is the first quadrant, so this over here is negative pi over 2, so that's quadrant 3, and this one, or quadrant 4 and quadrant 3. So you go back negative angles, you're going to get negative angles here. Okay, so let's find x then. So x is going to be, and they say find the value, so it's only 1 of x. So therefore x is equal to pi over 6 minus pi. That is, if you take that over there. All right. Or I can write it on the other side, so that at least I can write it on the other side like this. Still the same thing. Then this one remained minus pi. Whatever you do, you get that x is equal to negative 5 pi over 6. That's what you were supposed to do in that question. Okay. Right. Let's go to the part C. Now, there are very close similarities here, and I hope you can see the similarities that is happening here. One of the things is, if I go back to the first part of the question, and that was 5 root 3 cos, it was x, but I'm going to just leave it as that, cos x plus 5 sine x. We know that this was equal to 10 cosine of x minus pi over 6. But now in this particular case here, they have theta. So I'm going to replace this x by theta. Okay, so I'm going to write this as the integral of 1 over, then I have 10 cos of theta minus pi over 6. All of this squared, and now we are integrating this with respect to theta. Okay. So whenever you square, you can actually rewrite this as the integral of 1 all over 10 cos square of theta minus pi over 6. Okay, integrating with respect to theta. I must just also mention that this is going to become 100 because you're squaring. 10 square is 100, and when you square this, it becomes cos square. All right. Why is this so important? Because this can be rewritten as, I'm just going to continue here, I can rewrite this as 1 over 100, and cos, remember cos square becomes sec square. So that is sec square of theta minus pi over 6. And we integrate with respect to theta. Right, so this is where I expect you to know your rules. And what are your rules? Your rules are, and I'm going to write it here just as a reminder. Okay, see if I have enough space. I think I have enough space. What you should know is that if you integrate sec square of an angle AX plus B with respect to X, then it is 1 over A, and the integral of sec square is tangent of AX plus B plus the constant of integration. And essentially that's what I'm going to use over here, right? When I'm going to integrate, because I can actually integrate this, right? So this becomes the if you look at just to make sure that I've written it correctly, it is not just theta, but it is 3 theta. Okay, it's not just theta, but it is 3 theta. So that's what it is. Because I was now looking at that 3, which is like my value of that 3 is like this 1 over A. That's what it is within that formula. Is that making sense? Right. So integration time. So at the end of the day, this is 1 over 100 times 1 over 3. Then this whole stuff becomes what? It becomes the tangent of 3 theta minus pi over 6 plus the constant of integration. Okay, indefinite. So let's just find that, here in front, 1 over 100 times 1 over 3, that is going to be 1 over 300. Tangent of 3 theta minus pi over 6 plus c. And this is our final solution. We're supposed to integrate it. Right, so there are quite a lot that you have to unpack whenever you were doing this question, and it appears like you can get tired as you work, and you have to be very careful that you don't make mistakes. Like I was now highlighting theta, but it's 3 theta, and then you have all of this square means you write it in terms of the way that we have from our previous work, and this is coming from our previous work, right? This is from our previous work, and you have to link that. So now it's not x, but it's 3 theta. So this whole stuff is going to now be replacing this, and squaring that means you take 10 square, which is 100, okay, and then which is here 100, and then if you write cos, then you can put a square next to it like this. It means like this whole thing squared. Exactly that's what it means. But you are now integrating with respect to theta. And then from there, you should definitely know how to integrate sec square, because 1 over cos square of an angle, and I will just write it maybe over here as well so you can know. So we have 1 over cos square x is nothing but sec square x. Also another thing that you are supposed to know, and that is how this 1 all over cos square became sec square of that same angle. Okay, and then obviously now you integrate, and hopefully you should definitely remember how to integrate sec square of ax plus b type, and that is exactly what I did in order to get to this final answer. Okay, that takes me to question 8a within the paper. Now they are saying differentiate that. Now obviously I hope that if you have something like this, maybe I can write it as a quick rule, I don't know. If you were to differentiate d by dx of something of this type, so the natural log of ax plus b, I'm not sure whether that is within the formula, but this should definitely become like you take the derivative of the stuff inside f prime, so it will be um, let me actually write it in a nice way so that you can get it. So if this was f of x, then it's going to be the derivative of f of x over f of x. Okay, so if I had something like what I have over here, and I'm supposed to integrate, because it's the natural law, or not integrate, rather differentiate, I'm going to say, okay, d by dx of the natural log of 2x squared plus 3, right? It's going to be the derivative of the inside, and the derivative of the inside is just 4x, that is 4x, all over whatever that is, the f of x there, not the whole of fx, but that whole 2x squared plus 3. So over 2x squared plus 3. So maybe we can just clean it up so that the rule makes a little bit more sense, because I don't really like the way it is. So we can say that this is actually, if you have a type like ax plus b type, and you are supposed to find the derivative of b is 0, so that's going to be a over ax plus b. That is basically what I'm trying to say, and that is this over here is the answer, okay, coming from that. Now when you are having a hence question, it means what you are now doing there you're supposed to use here, okay, because you're not doing how to derive this type at this level, but you should realize that integration is the reverse of differentiation, antiderivative, so to speak. So you have over here the derivative, and if you have the derivative of 4x all over 2x squared plus 3, if you have to derive this, it's going to give you this answer, because if you have the derivative and you go backwards, you get to the function, right, which is that. But this function is the one that we have. It doesn't have a 4 over here, so I'm just going to go ahead and put 1 over 4 here, so that 1 over 4 times that sort of cancel, and it's a clever way of writing that very same thing that is there. So this whole answer over here is equal to this part over here, right? So if you integrate this, that's what you're going to get, and you're just going to multiply with that 1 over 4. So this 1 over 4 actually is sort of a clever way of saying, how can I make this just to be x on its own? So at the end of the day, that realization just means that the answer is 1/4 times what was the original function, is the natural log of 2x squared plus 3. Then it's the natural log of 2x squared plus 3, and then plus the constant of integration. All right, and supposedly we have got, you can put absolute value signs, but even if you leave it like this, it's definitely going to be fine. So maybe I can just write that comment so that you can definitely note. You should definitely realize that that integration is the reverse, is this antiderivative. Derivative. Okay, that's what it is. So when you have the derivative going backwards, that gives you to the function. That's it. Question 9. Right. We are supposed to solve the equation. Right. This is 3 and you have absolute value of 1 minus x here, and 9 becomes 3 squared of x. Now you can drop those bases. You have the absolute value of 1 minus x is equal to 2x. Then there are two ways to solve this. You can solve it by saying 1 minus x is equal to negative 2x, or the other one is 1 minus x is equal to positive 2x. That's how you solve it, right? Right, so in this particular case, if you were to solve, this is going to be minus x plus 2x is equal to negative 1. This is x is equal to negative 1 as one solution, but I'm going to come back to this. Or if you do this one, you're going to get 1 is equal to 3x. Therefore, in this one, x is equal to a third. Now, let us see, because whenever you are dealing with absolute value equation, it does you all the good in the world to check your solutions and to see whether your solutions checks out. So I'm going to substitute them in here to see if the left side will definitely give me what is on the right side. So checking for this one, I have 1 minus negative 1, and this answer is actually the same as that, which equals to 2. So this is what it looks like on the left hand side. Then on the right hand side of that same thing, if I was to substitute that negative there, which is the 2x, then 2 times negative 1, can you see that it's negative 2? Then you can see that the two answers are definitely not going to check out, so x cannot equal to negative 1. Well, if you were to check for 1 over 3, you will definitely see, and I will leave that for you to do on your own, that it works for that one, and that is going to be the answer. So you put negative where I have indicated negative 1 here, and on the left and as well on the right, see if the answers are going to be exactly the same, and if that is the case, that one becomes the solution. Okay, right, let's then go to question 10. They are saying, so the question still deals with the absolute value or the modulus topic. They say you must sketch on the same diagram those graphs. Now, before you did, I hope by now everybody should know how to sketch this graph, not a problem. Okay, here how do you sketch this type? So what you do is you find what is called the salient point, that is like where that vertex is, and you do this by saying 2x minus 11. If you say let that equal to 0, and this is going to be that x is equal to 5.5. So I know now where that v will touch. One more thing, where would this graph cut the y-axis? It will cut the y-axis, intercept the y-axis where x is equal to 0. So if you have y equals to 2 times 0 minus 11, then you will have y equals to the absolute value of negative 11, which is 11. So it will intercept this is the y-intercept, and the y-intercept happens when x equals to 0. So I can actually, let's see the space that I have to work with. I can actually do my graph if I have to. Let's say I go from here. Okay. All right, so here we go again. So just bear with me. All right. We're going to close, and hopefully it recovers everything. Hopefully it recovers everything. Here we go. So open with the annotator, and let's see. Let's restore. Right. Let's remove this. I want it to be in black. Okay. Right. So let's say something like that. Okay. And let's say the other one is going to be something like this. Makes a bit more sense. Okay. And then what do we have? we know that this is obviously the y-axis. We know this is the x-axis. What else? I know that I will have a v-shaped graph, okay, because the value of a is positive. So v-shaped graph that will go from here and then it bounces back, okay. What else do I now know? I know that it is cutting here where x is 5.5 and where that is 11. That's it. So this is the absolute value graph. And the other one, well, for this one, it will cut the y-axis at -3, but where will it cut the x-axis? And it will cut the x-axis where y equals to 0. So 3x minus 3 equals to 0. This will give you that x is equal to 1. So I can actually go ahead and draw that graph, and that graph is just a sketch, remember, is going to go something like this. And what do I know? I know that here it's going to cut at +1, okay, from that, and here it's going to cut at -3 from obviously that. It's the y-intercept. So the blue graph represents my straight line graph, and the red graph represents the absolute value graph for 2 marks. I think I have listed the important things, and let me just put the origin over here. We get. Now they say solve the inequality. The way you will be solving this inequality at B, right? You will have to think a little bit in terms of what is it that they are asking when I use the graph. If I say, let me use the graph, where is the absolute value graph below the straight line graph? Okay, that happens here. From here, it's going to be below. So if we can get whatever this x value is, right? If we can get whatever that x value is here, then our answer, let's say that x is some number, we don't know what that number is, but this answer will be x is greater, okay, or answer should be whatever our answer should, x must be greater than whatever this is. Let me say that is 0.8, should be greater than 0.8. That is the answer that I'm expecting here in this case. Are we good? So what will I do? At the point where the two graphs are intercepting, the two functions are exactly equal to one another. So I'm going to say, why don't I just equate? But I'm not going to equate the absolute value. I'm just going to take this leg, this negative leg of the absolute value graph. Can you see that? That negative leg of the absolute value graph. Okay? I'm going to take that, and so I'm going to say, take that minus 2x minus 11. Let it equal to 3x minus 3. I'm not interested in the other part. I'm just interested where they intersect. So they take the negative leg of that. So it's like a line here and another line here. Here the line is 2x minus 11. If you were to continue with this line in normal one, it will cut the y-axis somewhere at minus 11. But absolute value graphs have that where they now sort of reflect back. Okay, so that's what I'm looking for. And that's what I'm doing here to find whatever that value of a will be, what I did there. Right, so this is minus 2x plus 11. If you distribute over, okay, this becomes something that can be solved much easier. This is going to be 11 plus 3 is equal to 3x plus 2x, eventually giving you 5x is equal to 14. And at the end of the day, this is then that x equals to 14 divided by 5. Therefore, x should be greater than 14 divided by 5. And this is the answer we are looking for, okay, in our inequality, as I was now indicating here, right, at this particular stage, right. And you know that 14 over 5 is obviously going to be a number that is far less than 5.5. It makes sense then. So that is the solution in that way. But the graph sort of gives you an indicator for you to see what is it that we are actually supposed to do. Let me just make sure that because whenever this thing happens, I must make sure I save. All right. Then there is a C part. I want you to see similarities, and you have to come to a realization of something. So I'm going to write down this over here. That becomes 2x minus 11 is less than 3x minus 3. What do you realize? You realize that the natural log of n is equal to x. That's what I want you to realize there. That the natural log of n, they can't have a small letter there, otherwise it would not make sense. Can you see that? Why they had to make that a capital letter? This is equal to x. What is our x? From here, from part B, we know that the natural log of n should be greater than 14 over 5 because the natural log of x is replacing x. So this is something that we should be able to solve. Right. This is going to leave me with n is greater than e raised to 14 over 5. How do I go from that? Remember I said natural log is log base e, so e raised to that. Okay. Now let's see what that is, what that gives me. N is greater than what number? Because we are looking for an integer, we are looking for a positive or negative whole number, but an integer value. So e raised to the power of, oops, Daisy, shift e raised to the power of 14 over 5. Okay, this 16.44 and so on, 446. This is 16.446 and so on. What number is greater than, what integer is greater than that? Therefore, the integer must be what? 17. That's the next number that is greater than 16 point something. Okay, that's the solution. That's what we are looking for in this case. Right, let's then look at question 11. Question 11, obviously you deal with iterations, by the looks of it. All right, they say show or verify that a calculation, by calculation, that the equation, the natural log of x is equal to 2e raised to the minus x, has an answer or a root that lies between them. So at 1.5 and at 1.6, what do we get? We have the natural log of 1.5 minus, so I'm going to write this as natural log of x minus 2e raised to the power negative x. That's what you do, should always equal to 0. That's what you should do, okay? Minus 2e to the minus 1.5. See what I get when I use the calculator there. And then the same applies 1.6, that is minus 2e to negative 1.6. If I get opposite signs, okay, values, then I know I actually will like you to work it out, okay? So, or let's see, natural log of 1.5, if there's a change of sign, then the root lies between those points, okay? Minus 2, and then e to the negative 1.5. It equal to, right, so I'm just going to take all of that and I'm going to just paste it. You are going to write, and please write it out to at least more than 3 significant figures. They didn't indicate, as many decimal places as you can. So I'm going to go back and I'm going to put 1.6 so I can see what I get. That was a negative, and this answer should be positive. And if this answer is positive, which indeed it is, then it means that there is a change of sign, so therefore that root lies between that, as you can see. So you do that, you write those values down, and then you write change in sign. So the change in sign, okay, that will indicate that the root lies between those points. Right, then part B, show that for 1 mark that the sequence of values given by the iterative formula, right, converges. Then it converges to the root of the equation in part A. What was the root of the equation of part A? Well, the root of the equation of part A was the natural log of that. So basically, what is it that we can do here to show that that will converge? So the first thing is, where I have the x sub n plus 1 and the x sub n, I'm just going to replace them with x, basically. So it's going to be x is equal to e raised to the 2e minus x. I'm going to take away those n's. When I'm here, what do? Well, we take the natural log of both sides because we have e here. Natural log of that equals to the natural log of e raised to the 2e minus x. Okay? Then at the end of the day, this will definitely give you what we're looking for. That's the natural log of x is equal to 2e minus x times the natural log of e, which becomes 1. Therefore, the natural log of x is equal to 2e minus x, which is it minus this one to see. This minus x, totally wrote it wrongly. It is actually an exponent. Okay, it is to the minus x power, minus x power, and minus x power. It's the way it's written there. It would be a little bit confusing. And as you can see, this obviously is exactly how that one was given in that part. That's all that you needed to do. Okay, then they use the iterative formula in part B. So we have to use this formula here and find what that value is that it converges onto. So I'm just going to grab that, paste it over here. Oh my goodness. All right. Here we go again. Let's open again. And hopefully it restores. And surely this is the last paper 2 that I'm working out. Then I'm going to do paper 1s, even the Khomas paper 1. I will do so. So now if I hit save, then it wants a different answer, so I'll just do that. Right, so how do you do this? And they want you to give the answer as you are doing the iterations to 5 significant figures. The first thing you do is to obviously grab your calculator and make sure that it's clear within your calculator. So this e to the 2e minus, so the first one that they want, the initial value is 1.55. So you press 1.55 on the calculator. So 1.55 you hit equal to. That's what you do. Okay, and then you now put in your function, that is e raised to the 2e to the minus x. So raised to the 2, okay, just follow with what I'm doing there. 2e, oopsie daisy, raised to the 2e. It automatically, when you put that, put a negative. Now I'm not going to put 1.55. I'm just going to say answer because it's within that. Right. So I'm going to press equal to every time. So the first one is given, and I'm going to write it like so. The initial one is given as 1.55, but it's going to be the second one. And you don't have to write x sub 0 or x sub 1 is equal to that. Just press equal to. And I'm going to just take screen captures. You obviously can go ahead and write them down if you want to. I press equal to again, see what I get. That's the only thing you do. Okay, and how many of these will I do? Well, remember, I want to see to three, is it three significant figures, 1.529, 1.543. I want to see what does it converges to. Hit equal to again. Sometimes you have to show about 6, 7, 8 of them, but we're not going to give you where you have to go 20. What is this 1, 2, 3 significant figure? This was 1.543, 1.534. We're not there yet. Hit equal to again. I think it gets now closer to where we need to be. I'm going to paste it over here to 3 significant figure 1.53. Okay, then it won't change it. So let's do one more. Okay, capture screen. Then let's see what does it give me. 1.534. 1.53. Okay, one more. Let's see. I think I get closer. 1.5 capture screen. So let me paste that. Taking these two into account, 1.528, 542. Okay, I think I went way overboard. I was now looking at decimal places. It says three significant figures. So three significant figures: 1.54, 1.53, 1.54, 1.54, 1.54. Our answer is 1.54. Okay, three significant figures, and then x is equal to 1.54. That is to 3SF. There was no need to do all of this. 6 should have done it. 1, 2, 3, 4, 5, 6. By here, I'm already determining that we are getting to 1.54. To 3 significant figures, 1.54, 1.54. Right, so there's where you ended. I just did one extra. You also see that I'll get 1.54. And that is the solution here to this one. To 3 significant figures. When you are writing your iterations, you should definitely make sure that at least your iterations are to 5 significant figures. So you write them to 5 significant figures. Obviously, because I am using the calculator and I was just capturing the screen, so I don't have to rewrite because I need to continue to do it. And it was much easier to do so. But in the exam, you have to write them to 5 significant figures each time for you to be able to see what do they actually converge to 3 significant figures. So that root is going to be 1.54. All right, this brings me to question 12. Question 12 is surprisingly the last question of this paper. Just wanted to make sure. The diagram shows the curve with the equation. The shaded region is bounded by the curve in the straight lines x equals to 0, x equals to 6, and y equals to 0. They say use the trapezium rule to find an approximation to the area of the shaded region. Our final answer will then give to 3SF. Right. One of the things you should know is that H is equal to B minus A divided by N, where N is the number of strips, and they will tell you if you read, this is also a hint. They say how many intervals. Those intervals, the apisia, the number of strips, that's what you're going to have. Our B in this case is 6 and our A is 0. So H would be 6 minus 0 divided by 3, which just gives you 2. Okay, this H is your width. Okay, that's your width. So effectively, what does it mean? There will be 3 intervals here. I'm going to see if I can do a job here. So you're going to have, how many 3's in? 1, 2, 3, 4. We're going to have 4. So that's going to be 1, 2, Okay, something like that. Ne? So how many trapezia are you checking? Well, you'll see that we have 1, 2, 3, 4 trapezia. Does that make sense to you? Okay. We call them we call them the ordinates. When you look at all ordinates, ordinates is always one more than your strips, right? The ordinates is going to be 4. The ordinates is these vertical lines, right? If you know um, when you are giving Cartesian coordinate system, the y is the ordinate and the x is the abscissa. This is what we are referring to as the ordinates. The ordinate is always one more than n. It's always one more than n. So n is equal to 3, so they are going to be 4. Okay, and these are the number of trapezia that you can see. Also, you have got 4 trapezia that you can see. If they were to ask you whether this area is an overestimate or an underestimate, and as you can see, it will be an underestimate. As you can see that there is still some little area left under that concave curve. Now let's then see what you do. So these two, by the way, which I can also call the width, is actually the distance, just this distance over here. That's what it is. The distance over here, that 2, that's the width of each one. That's what that means. You understand what I mean? So that's what that means. Right. So if we now say, okay, let's create to see what will be the height. If I input an x value here, what is the height going to be? And that is going to allow me, so I can start with the first x value, which is going to be 0. What is the height going to be? The height, that means what is that gonna hit me there? So I'm gonna create a table, which is an easier way to deal with it. You create a table, and I'm gonna create a table like so, and I'm going to start off with the first value. Okay, and how many of these do I expect? I expect 1, 2, 4 of them. And I'm making it a little bit bigger because of the way that I'm going to write those answers. Oh my goodness gracious. Yeah, even if you hit continue, it still doesn't. Let's see. I just close it, and hopefully it's frustrating, and it happened quite a lot. So please do invest in the channel. About 70% of you who watches my videos have not subscribed to them at all. Okay, and that is a problem. You cannot have that. So subscribe and then get in contact with me to see how we can make it a success. Anyway, the value of x that I'm going to have, the first one is going to be 0. The second one that I'm going to get is I must now move 2 places. So x is 0. Now the next one will be 2. Okay. The next one, add that width, is going to be 4. And then the next one will be 6. That's what we are looking at. Okay, so you are adding the width or your h2 as you're going along there. You now substitute this into the formula. And what is the formula? The formula is y equals to root 1 plus e raised to the 0.5x. That is what we're going to do to see what outcome are we getting, and we're going to write those outcomes there. Okay, so let's grab a calculator and see. I'm not going to use decimal values. All right, so what I know that every one of my answers is just going to be under the square root. Hopefully you understand. So I'm just going to say 1 plus my e. What do I have? 0.5 times 0. When you take 0.5 and you multiply it with 0, it will just be 2. but it's supposed to be square root of 2. Remember I said that everything there is under the square root. Okay, I don't want to put the square root so that the calculator gives me decimal values. And what is x here? X here will be 2 now. So I'm going to go back and I put a 2 there. But everything is still under the square root. Oh my goodness. I can actually just do it manually. Okay. If you put 2 there, you're going to have a half of 2 is just going to be 1 plus e. That's what you're going to have. If I put a 4 here, that's going to be square. That will be 1 plus e squared. Or you can write those decimal values down. It's totally up to you how you want to proceed. 1 plus e cubed, if I put a 6 in the place of the x. But everything is still under the square root. I'm just doing that so that I don't have to do much, of writing all those decimals. But you have to substitute those x values into the formula for you to do so. Right, what do we know? Now you know that whenever you integrate, and you will find this in your formula sheet, but I'm not necessarily a fan of the way this formula is written, okay? And I'm just going to perhaps grab it, and I hope that nothing bad happens when we deal with that. Just going to paste it directly there for you to be able to see where I'm going with it. Right, so this is the trapezium rule. And also your h, can you see, if you don't know what h is, it's also given to you in your formula sheet. But I'm not really a fan of how they are writing it here. Okay, so this is how I would suggest that you remember them, the trapezium rule. If you're integrating a function with respect to x for the limits from whatever they are, in our case it was 0 to 6, this answer is approximately our width, right? Half of our width. Our width is, by the way, the value of h that we calculated. That's why I put that there, right? That's why I put that there. Our width. And then what you're going to say, put a square bracket. Then you are going to find the first height. This root 2 that you are seeing here, this is here, root 2 is the first height when you put 0. And that other one will be the second one, 1 plus root 1, or the square root of 1 plus e, and so on and so on. So that is the first height. So I'm going to say first height. So I'm just going to write first height here, plus 2 times the middle ones. The middle ones will be this one, square root of 1 plus e plus the square root of 1 plus e all squared. That, okay, not all squared, but the square root of 1 plus e squared. That is what's going to be the middle heights. I'm just going to write it something like this. And then you add the last height, which is this one, the square root of 1 plus e cubed, which is the last height. Right. And that is what the trapezium rule is. That is what they are seeking to explain here. But remembering it like this quite helps a bit. So if I have to write, obviously if I have to write that integral, so it's approximately equal to, in this case, I'll write it like this, just so that you can follow. Let's use maybe a different color code here. The integral from 0 to 6, I saw, of the square root, what was that function? The square root of 1 plus e raised to the 0.5x power with respect to x is approximately equal to our width, or our h was 2, so it's 2 over 2. Our first height, guess what our first height was? Square root of 2. So you go ahead and put square root of 2 plus twice. So maybe I will change this one. Plus 2 times the middle heights. And what are the middle heights? The middle height is this one. 1 plus e plus, okay, that's the middle one, square root of 1 plus e squared. Those ones are the middle ones. Can you see that? Then plus the last one. What is the last one? The last one is 1 plus e, oopsie daisy, 1 plus e cubed. All of that. Right. So if you are now dealing with, say for example, on your calculator you have got the square root of 1 plus e. I use this 1 plus e. Can you see? You will have decimal values that you put in, and so on and so on and so on. Right. I'll leave it to you. I'll let it pause a bit, and I'll leave it to you so you can see that this answer will be approximately equal to 15.7, and they did say we must give our answer to 3 significant figures. So as we were instructed, to 3 significant figures over there. So I will let it marinate now and play around with the calculator and see that you do get to the answer of 15.7 units squared, and that is obviously correct to 3SF. Right, so this is the end of the question paper, and well, this one was a little bit tricky in terms of the software acting out or acting up, and as a result of that there were times where I had to restart it. Luckily it restores the previous work, and please do go through the paper again if you have access to it. I will be sharing it on my Google Classroom codes, where you can download them, or you do get in contact with me, so that I can actually forward it to you, provided you give me maybe an email address or something, okay, that you can forward um, your questions or things that you have, and you can reach me at this address, gmail.com. Okay. Another thing, subscribe, because again, as I was saying, there were 70% of you who are watching the videos are not subscribed to the channel. So we can improve the algorithm the more you you subscribe. Um, Obviously, also to see how you can support the channel. Yeah, so that the project can just grow. Yeah? So we can grow this project. All right. Okay, so that is it. This was paper 2. I will definitely be looking at paper 1. And you see the way that this document is. I save it as a PDF. I can also share it with you as a PDF. And then you can definitely also have the solutions, so to speak. Right. Good luck with your studies. And again, as I said, this one was really interesting. There were a couple of questions that might be a bit tough, but it was really an interesting paper.